Hey everybody, in this video we're going to be working with complex numbers, section 4.8, complex numbers. Complex numbers happen when you have the square root of a negative number. That's where they come from. They can be written in terms of a real part and an imaginary part. So all of the numbers that we've worked with so far have been real. They've been fractions, they've been decimals, they've been integers, they've been things with never-ending decimals like 3.14, which is going on forever, is pi. Even like the square root of 17. We know that the square root of 16 is 4, but the square root of 17 would be like 4.1, and then it goes on and on forever. Even though that decimal place goes on infinitely, it's still a real number. Complex numbers only show up when you have the square root of something negative. So to begin our discussion, let's define the imaginary unit. So the imaginary unit is I, and I is simply the square root of -1. Now, if you took and you squared I, then you'd be looking at the square root of -1 squared, and I squared would end up being -1. So the cool thing about imaginary numbers is that they show up in a 4-part pattern. And that 4-part pattern looks like I to the first, I squared, I to the third, and I to the fourth. Well, we already know that I is just I, and we know that I squared is -1. Now, I cubed is going to be -I, and I to the fourth will be +1. So you could expand the square root of -1 times itself 3 times and see where we're going to get -I, just like you could expand I to the fourth, or the square root of -1 4 times and see where we get the +1. So if you can remember this 4-part pattern, then you're going to be all set for dealing with complex numbers. In fact, I remember when I was in high school, my algebra teacher said it's a 4-part pattern. I won! I won! And the 2 in the middle are negative. So, you know, it's like you're exclaiming, I won! I won! Maybe $1 million. The 2 in the middle are always going to be negative. So something else that's pretty cool about complex numbers is that they can be graphed in the complex plane. So normally we would call the horizontal axis x and the vertical axis y, but in the complex plane, x is where we put a and y is where we put bi. So for example, if I wanted to plot something like 3 minus 5i, what I'm going to do is go right 3 and down 5. So go to the right 1, 2, 3, down 1, 2, 3, 4, 5, and then here is that point. This is the point 3 minus 5i. Notice how that in the complex plane, numbers aren't given as an ordered pair, they're given as an a plus bi. So we're thinking a plus bi. Now, something else that we're going to do is find the distance from the origin to this point. So the distance from the origin to the point 3 minus 5i can be found by taking the square root. So I'm going to put d equals the square root of the real part 3 and then the b part, which is 5. And we're going to square that. Now, you don't really need to worry about if it's a +5 or a -5. Maybe I should put in a -5 just for safekeeping, because whenever you square it anyway, you're going to end up with something positive. So this is 9 plus 25, which is the square root of 34. So the distance, or the length of this, we're going to soon learn that this is a vector. The distance of this segment from 0 to 3 minus 5i is the square root of 34. All right, I feel like I've thrown a lot of new information at you pretty quickly. Let's just kind of slow things down and take a look at some examples. All right, so let's slow her down here. Can we simplify the square root of -24? So I want us to simplify the square root of -24. Well, right off the bat, I know that this is going to be something I. So the negative underneath the square root, this part becomes the I. Now 24, is there a perfect square in 24? There is. 4 times 6 is 24. I know that the square root of 4 is 2. I don't know what the square root of 6 is, so I'm going to leave that underneath the square root symbol. So the square root of negative 24 is going to simplify to 2i square root 6. Why don't you rewind the video if that was kind of, if that went, zooming past your head. Let's take a look at letter B, the square root of negative 100. Well, again, I know that this is going to be something I, and that's because the square root of a negative number gives me that I. Now, I also know that the square root of 100, the square root of 100 is just 10. So the square root of negative 100 would be 10i. Done with that. How about a third example? Let's take a look at the square root of negative 9. What is the square root of negative 9? Well, I'm going to tell you right off the bat. The answer is negative 3. So why isn't there an I in this answer? There's not an I because there's no negative number or negative symbol underneath the square root. The negative is not underneath the square root. So this is not an imaginary situation. Okay, two more. I would like you to plot. I'd like you to plot negative 5 plus 2i. So let's see about plotting negative 5 plus 2i. What are you going to need to do? You are going to need to go left 5 and up 2. So we're going to go left 1, 2, 3, 4, 5. And we're going to go up 2. And here's the point, negative 5 plus 2i. And then in the last example, let's find the absolute value of negative 5 plus 2i. So I put this in absolute value bars, but really what this means in complex numbers is the magnitude of the vector. The magnitude specifically of the vector that goes from the origin to that point. Now vectors are always going to give us direction and magnitude, so I put a little arrowhead on the end. The arrowhead is not super important right now. Don't worry about that. Just know that the absolute value bars mean we're going to take the square root of each component. So the horizontal component or the A component, which is negative 5, and then square it, plus the vertical component or the BI component, which is 2 squared. Don't worry about the I. Do not worry about the I. And then we end up with, what would that be? The square root of 25 plus 4, which is the square root of 29. So the magnitude of this segment from the origin to that point, negative 5 plus 2i, is the square root of 29. All right, that's it for today. Good work.